Okay, welcome back on a Monday morning. This is May 6th. I know we've had a long hiatus, especially for band students who have been pretty well off for like an entire week. I have only been here one day in the last week, so hopefully this will help you get caught up. So we have four questions here from Chapter 10 on circle geometry. The first question looks complicated, but it's just about inscribed angles and central angles. The second question here is still about inscribed and central angles, except it deals with a diameter, which is a variation of inscribed and central. The third question is about perpendicular bisectors, and the fourth question is from 10.3 on lines tangent to circles. So we're going to start first with this question here. And the question actually, I think, says what is the angle of x and what is the angle of y? So the first thing I would do if I was given this question is I might take a marker or a highlighter and I might actually just do in red the central angle that A and B connect to the middle with. So I know that A and B connect to the middle of the circle and form a 40-degree angle. So if this was my test, the next thing I would do is say, okay, does A and B connect to any point outside of that central angle? And it does. It connects to point E. So I would do that all in the same color. And I would therefore be defining both my central angle and the inscribed angle, and the relationship between the two is the inscribed is always half as much as the central. So since the central angle is 40, that must mean that x is 20 degrees. Okay? And then I would repeat the process, and I would probably use a different marker and not drop it. And I would say C and D connect to the middle, forming a central angle of 100 degrees. Now C and D also connect to point E outside of the arc, and therefore angle Y would be inscribed to the central angle, and therefore angle Y would be 50 degrees. Okay, so that's just the relationship between central and inscribed angles, and probably if I had to do it again, I probably would have given you a different question. I probably would have erased that and erased that, and I probably would have put Y here and 50 here, and then asked you to define Y there. And that point you would have been given the inscribed angle, because there's the inscribed angle of 50, and therefore the central angle that connects to it would be double that, and that would have been 100 degrees. Okay, variations of the same type of question. Your second question gives you AB as the diameter. It says up here, AB is the diameter, and it's 10 centimeters long. So I can say that it's that long. Now, if it's a diameter, we know it's a straight line, and straight lines have 180 degrees in them. Okay, so in addition to being a length of 10 centimeters, it's also a straight line. And since A and B are connected to the middle, this 180 degrees is not only a straight line, but it's also a central angle. And A and B, just like our last question, A and B are connected to the middle. A and B are connected to point C. So point C would be inscribed to the central angle of 180, which would make it 90 degrees, which would therefore be ACB is 90 degrees. And when I take this shape, of course, now I see that it's a right triangle. I drag this green triangle out, I rotate it so I can see it a little bit better. I put my 90-degree symbol in there. And now I have a Pythagoras question. AB is really the hypotenuse of this right triangle. Right, the diameter is the hypotenuse. BC is this distance here. And the distance AC, which we're looking for, is this here. So I can use either my formula or just squares. The area of this square would be 100. The area of this square would be 16. Now remember, the area of the squares attached to the legs add up to be the area of the square attached to the hypotenuse. So what number plus 16 is 100? That would be 84. And therefore the measure of line AC is the square root of 84, or approximately 9.1 or 9.2. I'm not going to use a calculator for that because I know the square root of 81 is 9. So the square root of 84 is either 9.1 or 9.2-ish. Question number 3 is from 10.2. We did it just before we left for the trip. And what it really talks about, it says AB is 4. So right here, this is 4 centimeters long. The radius of this circle, which is AB, is 4 centimeters. Now, because that is 4 centimeters, I'm going to know a whole lot of information in a bit here. The other thing it tells me is CD is 6. So this distance here is 6 centimeters. And we call those things a chord. So that chord CD is 6 centimeters. Now what I didn't say, and I should have probably done this and I should have had it there, is I should have said that AF meets that perpendicularly at CD. And I didn't say it, and if I don't say it, then all of the rest of the stuff we're about to talk about is not true. So I should have put that down because this is important. Because if a radius cuts a chord perpendicularly, so this is a radius, and since that radius cuts this chord perpendicularly, the truth that we learned in 10.2 is that chord will be cut into two identical parts. All right, it cuts it exactly in half. And that's the only real learning that happens here in 10.2. So AF is this distance right here. And the first question says, how long is AF? Well, since that's a radius, and this is a radius, the answer for AF would be, well, I know that radiuses are 4 centimeters, so it's 4 centimeters. And then it says, what is the distance of line AC? And AC is not even drawn there. So what I would do is I take my marker and I connect A to C, and I say, hold on, that's also a radius, so therefore it's also 4 centimeters. Okay, that's just identifying radiuses of a circle, which would be a grade 7 question. Now CE is this distance right here, and since CD was 6, and the perpendicular bisector cut it in half, then CE would be half of that 6, which would make it 3 centimeters. Okay, and the last question says, how long is AE? Well, as you can see here, I now have, oh no, that's not what I want to take. I don't want to take the blue one out. I now have, with this blue one, a right triangle, okay, of which I know that CE is 3. I know that AC is 4. And the distance I'm looking for is this distance right here of AE, x. Solve with Pythagoras. 16, 9, and don't know, but 9 plus 7 is 16. So the area of the square attached to that leg x, or that leg AE, is 7. And therefore, the distance of AE would be the square root of 7, or approximately 2.8-ish. I'm not sure. Those are always a little bit harder. Square root of 7, 2.6-ish. 2.6-ish. Okay. And that's the distance for AE. And your last question, even though none of you have probably even attempted these, we're going to talk about it today. So what we have here is a circle that has a radius, and all circles have radiuses. So I just drew it in right there. And we have this line AB that's outside the circle, and it connects to the circle at point D. This is called, point D is called the point of tangency, or the tangent point, or whatever you want to call it. C, the point of tangency. And what that means is, at point D, the radius and this line AB will be perpendicular to each other. Okay? So when I say a line is tangent to the radius, it means it's perpendicular. So right off the bat, when I see this sentence, I'm going to put this symbol in right here. Okay? And then I'm going to say, okay, AB is 12. So this whole line here, from here to here, is 12 centimeters. AD is 4, which means that BD, or the remainder of it, this one here, this part right here, would be the remainder of the 12. And if part of it's 4, that makes this line, and I should back up, hang on a second. That makes this line 8 centimeters. If this is 4 centimeters, and the whole line AB is 12, then that must mean that DB is 8 centimeters. And that should have been actually a question up there. So the first thing we're going to do is put 8 centimeters there. And the next thing says, since CD is a radius and CD is 5, I'm going to put that part in for the radius. Okay? And then the final thing says, AB is, or sorry, how far is it from B to C? So this distance here, I can actually draw that in. And that's actually the hypotenuse of a right triangle. This is 5, this is 8, and that distance from B to C, or C to B, is x. So again, I'm going to put my squares on here. This is 64, this is 25. This is the area of a square attached to a leg, this is the area of the square attached to a leg, so add those two together. I get 89. So therefore, the area of the square attached to the hypotenuse would be 89 units squared, and the length of x would be the square root of 89, or approximately, oh, wrong one, yeah, or approximately 9.4 units, centimeters long. Okay.